Let's take a look at how to create line plots. Dylan is studying bees. He records how many flowers each bee visits before returning to the hive. Use the data in the table to complete the line plot. All right, well, if I look at my table, I can see 2 bees visited 0 flowers, 8 bees visited 1, 8 bees visited 2 flowers, 5 visited 3, and 6 visited 4. If I take a look at the numbers across the bottom here, we call this the x-axis, right? The left to right numbers. These are all the flowers visited, right? 0, 1, 2, 3, and 4. So these must represent the flowers visited. So what I'm gonna do is try to draw an X to represent each bee so I can show how many bees visited each number of flowers, right? And if I hover over one of these numbers, notice it gives me these little X's. Each X would represent 1 bee. So for 0 flowers, there were 2 bees that didn't visit any flowers. So at 0 flowers, I'm gonna draw 2 X's to represent those 2 bees. For 1 flower, there were 8 bees, so I'm gonna draw 8 X's, 1, 2, 3, 4, 5, 6, 7, 8, right? An X for each bee, 8 X's for 8 bees. Okay, for 2 flowers, there were also 8 bees. So I'm drawing another 8 X's. For 3 flowers, there were 5 bees. So I'm only gonna draw 5 X's, 3, 4, 5. And for 4 flowers, 6 bees visited 4 flowers. So I'm gonna make sure to draw 6 X's. A dietitian noted the number of apples eaten by her clients last week. Use the data in the table to complete the line plot. Okay, and the clients ate either 0, 1, 2, 3, or 4 apples. Notice we see those numbers across the bottom. So these numbers would represent the number of apples. The numbers that you see in the first column, we call that the X column, are always going to be on the left to right axis that we call the x-axis. So the numbers you see in the second column, in this case the number of clients, that's going to be on the y-axis, which is what we call this up and down one. So the number of clients are the numbers we're going to try to represent above each one of these numbers on our graph. So notice no apples were eaten by 9 clients. Okay, so I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9 X's to represent the 9 clients that did not eat any apples. Okay, 1 apple was eaten by 2 clients. Okay, so 2 X's, right? 1 to represent each of those clients. 2 apples was eaten by 1 client. 3 apples were eaten by 2 clients. Okay, so 2 X's there. And 4 apples were eaten by 1 client. So 4 apples, I'm only gonna put 1 X. Jaden sells tickets at an amusement park and records the number that each person buys. Use the data in the table to complete the line plot. Okay, well, in the first column, or the X column, we have the number of tickets purchased. So those same numbers, 0, 1, 2, 3, and 4, are across the x-axis. So what I want to do is use the height of my stack of X's to represent how many people purchase each one of those numbers. So 0 or no tickets was purchased by 0 or no people. So I'm going to leave this blank. I'm not going to draw any X's over 0 since 0 people bought 0 tickets. For 1 ticket, there were 4 people. So I'm going to go over to 1 ticket and I'm going to draw 1, 2, 3, 4 X's to represent those 4 people. For 2 tickets, that was also 4 people. So that's also going to be 4 X's. For 3 tickets, that was 2 people. And 2 people bought 4 tickets. So I'm going to draw 2 X's for those 2 people over 4. Now notice when you draw it this way, it's just a little easier when you look at that data visually. Because when I look at this, in the table, I really have to look at those numbers and think and compare them. But when I have a visual, I can see without really doing much math, okay, 1 and 2 were the most popular, right? Those stacks are the highest. So it's really nice to have this visual to represent the data because it gives us some instant or immediate information without having to do too much math, right? It's just visually there for us to see. Sophia is recording how many solar panels are on each house in her neighborhood. Use the data in the table to complete the line plot. Okay, well, the number of solar panels, notice that's the first column in our table, so those numbers are going to be across the x-axis, and we see that 0, 1, 2, 3, and 4. So we want to draw x's to represent the number of houses for each one of those. Well, 0 or no solar panels were spotted on 8 houses. 1, 2, 3, 4, 5, 6, 7, 8 x's to represent those 8 houses. 1 solar panel was on 9 houses. Okay, so I'm going to draw 9 x's here. 2 solar panels were on 10 houses. Okay, so I'm going to draw all the way up. 3 solar panels were on 3 houses, so I'm going to draw 1, 2, 3 x's for those 3 houses. 4 solar panels were on 1 house, so only 1 x. And just like we noticed in the last problem, it's a nice little visual. We can see right away, okay, 2 solar panels was the most popular, and then 1 and none, and 3 or 4 was only a few houses in the neighborhood. So again, that visual data just makes it a little easier for us to pick up on patterns. Maya serves sushi at a party and records how many pieces each person eats. Use the data in the table to complete the line plot. Okay, well, across the bottom, or the x-axis, we have the sushi eaten, right? 0, 1, 2, 3, or 4 pieces. So we want to draw an x to represent each number of people that ate that amount of sushi. So for 0, or didn't eat any sushi, that was 9 people. So 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. For 1 piece of sushi, there were 5 people that only had 1 piece. So 1, 2, 3, 4, 5. 2 people had 5 pieces. I'm sorry, 5 people had 2 pieces, right? This is our people. So we're going to say 1, 2, 3, 4, 5 people for 2 pieces of sushi. 1 person only had 3, and 9 people had 4 pieces of sushi.